ang gayet mo lang, huwag mo nang, huwag mo nang record.
Wait,
Record na tayo. Okay, Sir Jay, thank you very much for
Okay
the
po.
free info for the free info. In the end, ito talaga ng mga things that we need to be conscious about.
Opo.
Okay. So today, I'd like to talk about geometry pa rin. Tapos medyo matagal na akong hindi nakakapagbigay ng mga things for you to work on. Tignan ko kung meron akong mga maidadagdag. So what I have is a random collection of geometrical facts. So ito, theorem. A theorem. The area of triangle ABC is equal to S times R. I think nabigay ko na to, tama ba? Or at least, can you imagine? So, okay na pala to.
I think it involves extended, hindi po extended love science. Ano kasi ito? Paano kasi na-derive pala nakalimutan ko
Kailangan
na.
ba ng extended law of science dito? Anyway, extended law of science, it involves the circumradius. Ito small r, the in radius.
Opo.
So ito, can you visualize?
In
Bakit kaya?
radius. Tapos, kasi po, di ba, yung in radius is perpendicular to all other sides, syempre.
Yeah.
So, one half yung, let's say po yung yung BC is A, para mas madali po na lang, para ano. Yung BC, AC, AC is B, and then AB is C. So, then po yung, tawag nun, kung i-divide niyo po yung triangle into three other triangles,
Ayun.
A to the in radius, B to the in radius, C to the in radius.
Okay, so ito, I.
Ayan po. So, then
So ito.
BIC is one half RA.
Ayun, okay.
Pag
Right.
inan ko po lahat, magiging A plus B plus C times R.
Okay, good.
Or 2.
Okay, so that's it. Ito naman. Itong next theorem, I'm gonna write down the statement, tapos let's try to work out the argument behind it. So theorem. The external bisectors of any two sides of a triangle are concurrent with the internal bisector of the third angle. Okay, so gagamitin ko ng space dito sa upper right. So we have a triangle.
Ginayang ko sa space.
Anong hinahin sa space eh? Hindi kasi so...
Meron daw pang free real estate, so dapat it must be claimed.
Oo, andun eh, sayang, ang white lang eh. So ito, A, B, and then C. So if you extend B, C, so external bisectors at B and C would be these.
Ito po yung Excircle?
Yes, doon tayo papunta sa Excircle.
Inisip ko po pa, naida ko pa lang external bisector. Parang it sounds like Excircle.
Oo. So ito equal, tapos ito, wait, gamitan ko ng a different kind of marking. Ito, dalawa. And then ito, 1, 2, 3, 1, 2, 3, and then ito naman. So equal yon. So show that itong 3, kapag i-extend,
Mukha naman pong concurrent for some reason. Ayun.
wag kang concurrent. Oh, syempre. Okay. Okay. So
siguro po, but hindi pala.
you're thinking Chavez theorem kasi we're talking
Concurrent.
about concurrency eh. Pero in this case, not necessarily. Okay, not necessarily. So
Baka pwede pong if we assume na to those two intersect, maybe we can prove that the other one intersects at the same point.
yes. So minsan ng mga concurrency theorems, pwedeng ganun. We can consider nung B, the external angle bisector at B and external angle bisector at C, tapos let them intersect, tapos show that the internal bisector of A goes through the same thing. Now, we know that the internal bisector of A definitely goes through the incenter, I. Okay? So, andun ang in-center. So, gusto natin, nung AI, dun pupunta sa point na yon. Okay. As far as I is concerned, syempre, the internal angle bisector at B, of course, it also goes through BI. Okay. Pero, what is true about the external bisector and the internal bisector at B? So, of course, did they
It
pass
looks
through
like
B?
they are perpendicular. I just don't know
Or
po. It looks like
Okay. So are they perpendicular kaya?
mm, ah
Ito, try to
maybe
think about it. Are they perpendicular?
po yung they are yung the internal angle and the external angle are supplementary. So maybe
Yes.
the other halves are complementary.
Yes. Actually, that's it. That's it. So nung external angle and internal angle are supplementary. So when you divide by 2, you would get 90 degrees. So that's why complementary nung half of the external angle and half of the internal angle. So kumbaga ito, say you have beta, beta, and then this is beta bar, all right? But these four betas add up to 180. So that means beta and beta bar add up to 90 degrees. So actually 90-degree angle yan. That is true for actually any internal bisector and any external bisector. So no matter the kind of triangle, acute or obtuse, and whichever vertex.
Cyclic
Okay.
quadrilateral.
Magsicyclic quadrilateral ba tayo? Pwedeng yes, pwedeng
BIC and the concurrency is a cyclic quadrilateral because IB let's say po D po yun. IBD and ICD are supplementary. So therefore BICD is cyclic.
Oh wait, hold on. So sorry, kunwari ito D and then E. Is that what you're talking about?
D po yung sa baba, yung concurrency.
Sorry, asan yung D? Where's D?
Yung sa point of concurrency between yung Excenter.
Yung tatlong
So actually, you're right. That's leading to the Excenter. So ito, ay, iurong ko ng kasi we need the
Magtatamaan.
space. Tatamaan eh.
Maghihinay space. Word surgery.
Yeah. So, nung usual symbol na ginagamit natin dito, I sub A. So, that's the Excenter opposite angle A. Kasi meron din Excenter na opposite angle B and Excenter opposite angle C naman. So, I sub A. So, wait, so you were saying?
So I was saying I B C I A without even knowing that I has I B C I A is a cyclic quadrilateral.
IBCIA. Hold on, sige. Wait, IBIAC is a cyclic quadrilateral?
I sub AC, yun. Cyclic quadrilateral.
Wait, I
sub AC.
Okay, I sub AC is a cyclic quadrilateral. How so?
Because I sub A and I sub A are supplementary.
Ano yun? Which ones?
I sub A is 90 degrees. And I sub A is also 90 degrees. So they are supplementary.
Gusto mo ano, P?
I see. I get what you're saying. Right. Kasi you have 90 degrees here and also 90 degrees there. Yes. In fact, you're so kahit hindi mo na natin isama ng nung extension from AI kasi we still haven't proved the concurrency. But yes, you're right. IBIAC is cyclic because of the right angles there. This is what you're saying, right?
Pwede mag-anatipin.
Dito ano itong...
Tapos, in fact, I sub A is a diameter.
Opo.
Okay.
Actually, yun nga po, since they are cyclic, then I sub A must be exist. Kasi siyempre diagonal eh.
Ganito. I sub A, we can connect them. But who's to say, maybe nung A, okay, A is here.
Ano collinearity naman?
And then I, tapos, what if nung I sub A, pag ganyan?
Ayan, Menelau's theorem po.
Hindi, I mean, I sub A, it doesn't mean that, tapos, wait, hold on. Okay, i-emphasize ko, pwedeng baliko kasi kunwari, ito ng I, tapos ito ng I sub A.
Okay.
Tapos nung A, pwedeng, what if ganun siya? Nung A. So, then lalabas, AIA is not the, okay, itong AIA, it's not the angle bisector kasi the angle bisector of A is AI. So it's not enough. We would have to show AI to IA, they're actually collinear. Okay. This is one way of doing this, and what this utilizes is a fact that's true about an angle bisector. So ganito. Fact. Let's say you have this angle with vertex V, and then this is the angle bisector. Tapos let's take any point.
Yes, the point is perpendicular. The can be perpendicular to both.
Okay, well, I mean perpendicular to both rays.
Abo.
But furthermore, from any point P on the bisector, when you draw perpendiculars, something is true about those perpendiculars.
They are same distance, same measure po.
They're equidistant. And in fact,
so kung ano pala po,
so in other words, P is on the angle bisector of V if and only if it is equidistant from the two sides of the angle.
So if we can prove, what do we need to prove? If we can prove...
So we want to show, AI is the angle bisector of angle A. A point is on that angle bisector if and only if it is equidistant from the sides of angle A. So which are sides AB and AC.
We only need to prove po that IAB and IA sub B and IA sub C is congruent, are congruent.
And then IAB and IAC, not quite. We have to show the distance of IA, para ito nung P, the distance of IA from, tapos ito nung angle A.
From B and C, ganun po ba?
Ano yan?
Kailangan alam na natin yan.
Na equidistant.
So you have to show IA equidistant from?
From B and C po.
Not from B and C. Ito, look here. Dito dun sa fact.
From the extension of AB
from B.
and from the extension of AC.
From BIA. BIA and CIA.
From the extension of AB and from the extension of AC.
Yes, from the side, from the side ang equidistance natin. Okay? So ito, again, no, kunwari ito, P is on the angle bisector. Okay? No fact, let me write it down. Okay? Okay. P is on the angle bisector of angle V if and only if P is equidistant from the sides or the rays of angle V. Okay. So, dun sa proof natin, okay, let the external bisectors of angle B and angle C meet at the point I sub A. Okay, so we want to show I sub A is on the angle bisector AI. Okay, but then using the fact in purple, this is equivalent to showing that IA is, kasi nung AI is the angle bisector of the angle whose sides are AB and AC.
Also po, when we prove that, if it's possible to prove that IA, the distance from IA to BC, yung ano po, yung ganon, is also then we can prove that it is the center of an Excircle.
So yun then, that's gonna follow. That's gonna follow. So we want to show.
Actually, kung alam po natin na perpendicular yun, yung IB, IA, and IC, IA, why are there two perpendicular? Wait, hindi pa na same. Okay. Medyo nalito lang po.
Depende kung saan perpendicular. So you have to be clear. Ano nung other side doon sa perpendicular angle. Okay, so this is equivalent to showing that I sub A is equidistant from AB and AC possibly extended. Okay, kasi pwedeng nung feet of the perpendicular nandun na mismo sa side. Although here from this illustration, the feet of the perpendicular go outside the sides AB and AC.
How do we know that IA is perpendicular to the extension of AB and to the extension of AC at the same time?
That's what we're gonna prove. That's what we're gonna prove.
Okay.
Kasi we have identified what it is we want to do. Okay, because this is the goal. So what we're doing is we are rephrasing the goal. Okay, so hindi pa natin alam that I sub A is equidistant from AB and AC, but as soon as we are able to do that, then that would take care of the task. Okay, because of the equidistance, if the two orange dashed segments have equal lengths, then that means I sub A is on the angle bisector AI of angle A. So that would mean the three bisectors described in the theorem are actually concurrent at the point I sub A. Okay, so ngayon, paano natin ipapakita nung same length of the two orange segments dashed? Well, we have to go back to ano ba ng I sub A? So ano ng definition ng I sub A? So I sub A is on the external angle bisector at B. Okay. Okay. So ano ibig sabihin nun that I sub A is on the external angle bisector of B?
Actually, yung para ma-prove po, you could use the triangles.
Okay.
So,
Yeah, paano?
yung ano po yung B, whatever yung ano po yung mga, yung one half of the external bisector. Wait lang. Hindi pala sila equal. Okay. Hindi pala mapaprove. Hindi po siya mapaprove. Hindi sila congruent. Okay.
So, hindi pa tayo sigurado. Anyway, ito given. I sub A is on the external bisector of B. So let me reconstruct part of the drawing. A, and then this is B, and then this is C. Let me move B. And then this is and then the symbol that I used was ito. We placed our mark here on the left side, written in purple text, what it means for a point to be on the angle bisector of the angle. So, okay, itong green segment, it's an external angle bisector of the triangle, the external angle bisector at B, but it's still an angle bisector. So if we call this point D, okay, so what we have drawn here is the bisector of ABD. For a point that's on this bisector, what's the consequence? If a point is on this angle bisector, then it means it is also equidistant from which sides? From which lines?
AB and BC?
Yes.
No!
AB. Okay.
I see it.
Kita mo na, but see, it's just, ayan. So ito. Kasi
it will also prove that it is also equidistant from BC. AB and
Okay.
AC, which means
So
it is also part of it is also a center of a circle. Man,
so
nice.
yun. Kasi di ba mga equal segments, the segments of equal length. Ito. I sub A is on the external angle bisector of B. Thus, I sub A is equidistant from lines AB and BC. Okay, however, I sub A is also on the external. Wait, you know what I'm gonna do, right? Because we need to be efficient.
Bro, why do you have to tell me what you're going to do? It's already it's like psychological torture just to even mention it.
Yes. Okay, next time magdo-drawing pa ako, gagawin ko pa ng video. Okay, for the torture to really be complete. So I sub A is on the external angle bisector.
I-play po pag ano.
If you play mo before ka matulog. Okay, so that means I sub A is equidistant from lines what naman?
AC ray and
Ito.
from AC and BC.
All right, from AC and BC. Let's use a different color.
So therefore, it is equidistant from AB and AC and also BC at the same time. So therefore, it is on the nga po. Nice. It proves it three birds with one stone, I think.
Yeah, oh, ang dami tayong. So, equidistant from lines A, B, and B, C. So, therefore, IA is equidistant from lines, kasi ito, wait, not from AB and BC, but here AC and BC. AC and BC. So IA is equidistant from lines AB and AC, which means I sub A is on the bisector of angle BAC. And this bisector of angle BAC is A sub I. Okay, so that means, so that does it. So that means the three bisectors, the external bisectors of B and C, and the internal bisector of A are actually equidistant from each other. Tapos furthermore, okay, back to the same drawing. So actually, I'm just going to reconstruct the drawing.
Reconstruct. Yay, nice.
So that I'm not gonna copy paste.
Ano po, it is a W for me.
So ito nung external.
Oh. Dapat pala mag-ano ko dito. Jeez.
No?
Yung glove. Para hindi mag-blister.
Okay, so we call this I sub A, and then A, B, C, and then here is I, the incenter. So we've shown I sub A is equidistant from lines AB,
AC.
from line AC,
and from line BC.
and from line BC. Okay, the drawing may not give justice to that claim, but those three orange segments, they have the same length.
I mean, it looks approximate naman po. They still look.
So pwede na, no? Pwede na. All right. So so if you look at these particular points, those 3 points, so that means I sub A is the center of a circle which passes through those those 3 points. And then if you
gamitin niyo po yung circle tool para hindi po mukhang parang nag-resurrect.
Parang pero kasi imperfect ng drawing eh. Imperfect ng drawing. Although ganito, hindi pa tayo tapos talaga kasi all we've shown is that I sub A is equidistant from those 3 points. Who's to say, Joshua, baka ganito ng situation. Okay, so all right, andito nung I sub A, it passes through this point and this point and this point, but you're thinking of the Excircle, and that's supposed to be tangent to BC, to the extension of AB and the extension of AC. Pero kasi all we've shown is that ito nga, this kasi 90-degree angle 90-degree angle. So, all right. Anyway, I wanted to point out, who knows, what if maybe the situation was parang ganito pala. Hindi pala siya tangent. Di ba? So how do you know ano? Kasi all we've really shown is that the
We can show it
circle.
po kasi yung tawag doon? Ah,
But how can we judge? How can
congruent
you assess
triangles.
na points of tangency nga talaga yun?
Opo.
It's because of the
At IA is IA to B A to AB is the same congruent, and IB to IA to AC is also congruent, and then AI sub A is congruent to itself, reflexive, and then we already proved that BAC and I sub A AC is congruent. So ano nga
let's
po?
go through that again, Joshua. Paano ulit yun? Say that again. I just wasn't able to catch up with what you're saying. So how do you know points of tangency yun?
So I sub A to AB. Yung ano po, the
So
two
ito
hash
yun.
marks. Two hash marks and the other two hash marks. And then I sub A is congruent to itself.
Okay.
And then BA I sub A and CA I sub A are congruent. It's an angle bisector.
Okay.
So therefore by ASA, AIA to AB, yung isa pong triangle, yung left big triangle.
Okay. So AIAB.
Abo, and
Oh wait, so let's call this ito P.
ayun po, AP I sub A and AQ I sub A. They are congruent. So therefore that is okay, good. Now we just have to prove that that is right.
But it would have to be right kasi from definition, yun nung dinrawing natin, I sub A is equidistant from AB and AQ. So the P and Q that we drew are the feet of the perpendiculars.
So I forgot po na it's required. But anyway,
so actually it's the 90 degrees there.
Opo. So since they are perpendicular, it means the radius is this radius and ano po? Radius and tangent.
Right. For tangent to AB. So some bonus observations. Okay. Bonus observation from this figure is that so with PQ and then so if we call this, but I hesitate to use R as again PQ big S. So bonus observation. Okay, I sub A is the center of the circle through P S Q. Okay. We call this circle the Excircle of triangle ABC opposite.
Meron pa pong uses po yung Excircle. Wala po ako nakita other than, I don't see any use for it. Yung wala po ako nakita mga references na nagsasabi may use for it. Other than the fact that it really just exists and there's a proof for it.
I mean, actually, ultimately, a lot of these facts are just observations about the reality of these figures. And they are relatively not that very difficult to identify or to observe. And ultimately naman talaga, when you carry out a mathematical exposition, a study of mathematics, the value is not so much in knowing the facts themselves, but in the practice of arriving at an argument kung bakit siya totoo or not. Okay. So if we're thinking of an application, posibleng gumawa ng problem involving Excircles. I may have seen a couple of problems involving Excircles. All right. Pero kasi as far as computations are concerned, mas may magagawa kang computation with Ptolemy's theorem, for example. So if we're looking for an application, depende rin talaga what kind of problem one is looking for. Kung mga proving, then malamang mas pwede magamit ang Excircle.
Opo.
So you call the circle the Excircle, an Excircle, and I sub A is the Excenter opposite vertex A. Okay. This Excircle is tangent to BC. Okay. AB extended.
Ano po pala, kung ginawa niyo po lahat ng mga Excircle, are the, what do you call that? Yung, kumaga po, yung analog ng I sub AS.
Mm-hmm.
So, sa mga ibang Excircle, are they concurrent? It looks like they are.
What do you mean? So, itong IAS? So,
Opo.
sige.
Yung analog na sa may ibang Excircle, it seems,
Sige, tignan natin mag-drawing tayo. Of course, pwede sa GeoGebra mag-drawing. Pero itong shape ay sausage nung lumalabas Gusto ko arbitrary.
real. Gawin na po yung line tool naman.
Line tool, sige. Paano yan? Shapes. Okay. And then, shape again.
Isosceles.
Wait. Shapes.
Ano ba construction in OneNote? Nobody thought this was possible.
Okay. Hey. E. No. Okay.
Oh, no.
All right. Okay, so that's a triangle. Uy, napagano. And then kaso nga lang dapat pala lines ang dinrawing ko rather than just okay. So all that gone. Kasi I would need the extensions of the sides anyway. So dapat mas habaan ko ng ano.
Gawin na po super liit ng triangle. Parang ano lang, parang shrimp.
Sige. Okay. Kaso nga lang, sige, pwede na yan. And then, ito.
Ano po, hindi, the base is not parallel to the bottom of the screen. Therefore, it must be...
nga
Puny triangle.
Okay. And then, one more. Pero parang isosceles Para ba itong right? Or
Ayan, dapat po pa medyo para siyang scaling ng mukhang equilateral.
Yan.
Okay na
Medyo
po.
scaling. Okay, now we draw circles.
Circle.
Of course, GeoGebra.
Looks fitting enough. Konti pa. Bruh?
Okay,
Literally nice.
So we will do hindi siya tangent, but sige, let's give it a bit of space, and then.
How do you know the center of the circle though?
Wala, estimate na lang.
No, but what if we use Thales' theorem to find the center?
Wait.
Rather huge.
Kasi gagalaw pa naman natin. And then,
Real. Yan po yung ano.
alright.
True genius.
Last.
I think po nagkulang sa space.
Yeah.
Huge. Parang medyo... hindi. Okay naman po yung circle. Circle-ish naman siya.
Okay.
Konti pang liit na ba? Konti na.
Dito sa upper. Alright.
Yes.
Sa center to center.
So, ano po, maybe para mag-ano po kayo ng estimate, tapos maybe you will estimate na rin po yung angle bisector para mas estimating yung ano. Kumbaga mas
Sige,
estimate.
meron ba tayong may angle bisection ba dito? Wala eh.
Bisection.
Wala eh. Actually, pag mag-angle bisector tayo dito, parang tansyahan na rin lang eh.
Okay. From the centers to the circle.
From the centers to the circles, but there doesn't seem to be parang, I mean, if I'm gonna select the centers to the circle, parang tansyahan na lang din eh. So, ito.
Mag-tansya po kayo ng parang right triangle para ano.
Ba't siya naging... Okay.
Ano po, racism against the circle.
There.
Yan. Ay. Yan.
Tapos the points of tangency, ito, I think. Not really sure where exactly, but itong center na to. Wait. I think the line.
Taas ng konti mo.
And wait. The point of tangency is not necessarily concurrent with the center. Okay, so ito, parang andito ng center. Pwedeng dito ng center.
Parang mas mababa po ng konti. Ayan.
Diba parang pwede na siyang radius in a center. That's it.
Close enough naman po. Close enough.
Okay.
Baba ng konti mo. Medyo pa yan. Lower right. Yan po.
Okay.
Tapos yung isa pa.
One more.
It must be approximately concurrent po to the
Wala pa pala tayo ng mga external angle bisector. Dapat i-add concurrent sa in-center. Alright. And then, if that's... Pero also then kasi... Wait, different color.
There's, they will
One color naman. Green.
touch the vertices.
Ano pa yung parang space na ano po, space na color. Whatever that is. With the crosshair.
So, ito dapat. That's B. So, lakihan ko na lang dyan. Okay. And then,
Had to hide our failures.
yes.
Ang figure na ganyan, no?
Wait.
Yes, it's like Monge's theorem. It looks like Monge's theorem a little bit. Not really, but it just looks like Monge's theorem. Yung tanong ko pa, di ba yung mga points of tangency are the what do you call that? The lines from the excenters to the points of tangency of the excircle, are they concurrent? Because it appears so.
Yeah, wait, label natin. A, B, C. Oops.
ABB.
I said, and then this is I sub A, and then this is I sub B, and then I sub C. So, for example, this one, external angle bisector of B, this external bisector of A, and then external bisector of C. So in fact, if you look at that orange, if you look at the triangle formed by, okay, so the triangle formed by the excenters, IA, IB, IC, and then ano nung mga orange, the orange segments are the internal bisectors. The internal bisectors, of course, they are concurrent, okay? Because in fact, the point of concurrency of the internal angle bisectors is the incenter A. So it's the incenter A. Pero ganito, if you look at the green triangle, relative to the green triangle, what is each of the orange segments?
I think it looks something. It looks familiar. It's
Altitudes.
Ayan, narinig ko si Sir J. They are the
altitudes. Oh, it's the center of the X triangle, sort of. What do you call that? Napoleonic triangle or something. Whatever.
wala pa tayo sa Napoleonic triangle. Pero actually,
Anyway,
Sir J mentioned it.
Whatever large triangle that is, it's the orthocenter is the incenter of little triangle ABC.
Ayan, actually that's where I'm headed for, Orthocenter. Kasi look, ganito. Di ba nung what angle is formed by through a vertex, the external angle bisector and the internal angle bisector? You pointed it out earlier.
Yung 90 degrees.
90 degrees. So that means you have 90 degrees here, 90 degrees here, and also 90 degrees here, which means that for the triangle formed by the excenters, okay, which is the green triangle, all right, the orange segments are in fact the altitudes.
Nice.
Okay.
So yung nga po, yung I8 yung are they concurrent?
Oh, yeah. So, nung halimbawa, IC and then
point of tangency.
Ito, no? Ito. That's an interesting question. Actually, I'm not sure. How about let's draw it on GeoGebra para parang they might be.
It looks very probable po that they are concurrent.
So I definitely want to answer that question. Tignan natin sa GeoGebra kasi what we get from this figure generally I'm proud of it, but it's still a flawed drawing, flawed picture. So hindi okay. Pero ito, I wanted to point out the Excenter
is the what do you call that
I
larger
of triangle ABC is the what kind of center of
Orthocenter.
triangle
But ano po yung tawag sa
IA
malaki pang center, malaki pang
I
triangle formed by the centers, the Excircle and Excenters.
actually yun yung iniisip ko. I'm trying to recall if merong tawag sa kanya. Is it the X triangle? Parang hindi naman eh. Parang wala akong natatanda ang specific name for that.
It is very familiar to me yung ganun po na triangle. But then I just don't know the name.
Sorry ito. Anyway, so whatever, so IA, IB, IC, its orthocenter is also I.
Nice.
So, ayun. And then, so for the, hindi na natin na drawing nung, hindi na natin na drawing nung in circle, but of course the in circle is also something that figures into the drawing.
Real algebra moment.
Nawala pa yung apps na hirap. Nawala pa yung mga apps na hirap.
Okay. So, sige, mag-i-algebra natin.
Nung wala pa po yung mga GeoGebra, mga hirap po, no?
Nung panahon, nung unang panahon, wala. Pero ito, para lang, for the interest of being able to answer the question.
Yung GeoGebra was, the best GeoGebra was ruler na po
Okay.
na measurement.
But then, of course, if we want to be sure, pwede naman natin i-drawing on pen and paper. It's just that online, mahirap gawin eh. So kasi wala naman.
Three-dimensional? Real.
And then let's just look is the two-dimensional. Okay, so we have ito, A, and then B, and then C. Tapos drawing natin lines na. Lines. A, B, and then C. Tatanggalin ko ng mga X and Y axes. And then, ba't nawala nung label? Show label.
Professional GeoGebra.
A, B, C. Tapos, let's draw the... Okay. In circle of A, B, C. Ayan.
Bro, little GeoGebra, this is cheating.
Cheating, no? Okay. Tapos, center of the conic section. Wait. So the in circle is C. So the center of the conic section C, the circle C, that's the in center. I-specify na natin. I is the name. I equals the center.
What? Literally na po JavaScript coder.
And then external angle bisectors. So angle bisector, well in this case, kailangan natin ng, hindi, ganito na lang.
So, ano po kayo ng arbitrary points?
Pero iwasan ko kumuha ng arbitrary points. Ganito, idodrawing ko na lang muna ng internal bisectors. Okay. Kasi remember, the external angle bisector is perpendicular to these internal bisectors. So itong internal bisectors, kulayan na natin sila para hindi tayo masyadong malito. Let's use green.
Very colorful.
First, yeah, some other color. Green. Okay. And then ito, perpendicular na lang. Perpendicular to this line at A. Wait. Select point and then perpendicular line.
Literally yan na po, literally yan ang literally JavaScript coding and algebra. No, it's real.
Okay, so ito na mga external angle bisectors, but let's color code. I think I used earlier orange. Mas mabilis, no? Object orange. Okay, so now let's draw the X circles. Actually, the intersections, these are the X circles. Liitan natin. Oh, so ayan, ito nung, so at this point, ito nung I sub A. Rename I sub A. So see intersection of two oranges, two external bisectors, and the green, the internal bisector. And then this is I sub B. And then this is I sub C. Rename I sub C. Okay, and then let's draw. Actually, one thing that I'd like to point out is the points of tangency. Anyway, that's what you're asking for, no points of tangency. But I'd like to include the in circles points of tangency as well. But first, nung sa ano muna? Perpendicular I sub A. I'm gonna get a perpendicular from I sub A to this extension.
What?
And then let's, kasi that's gonna be the point of tangency. But I'm gonna hide this line kasi para hindi masyadong magulo. Then this would be
mga pong parang laser na parang ang tawag doon. Yung parang laser na obstacle course or something.
And then, so ito, this is the X. So this is an X circle. Tapos here. Wait.
There.
So this is the intended point of tangency. I'm gonna hide this line para hindi magulo. And then Excircle. Then finally, from this Excenter, this is the point of tangency.
Look, po, it is also tangent to the other Excircle. I think.
Wait.
It just looks, it looks rather apparent. Kita mo.
What's tangent?
Yung ICF is tangent to the, it looks like it's tangent to the circle IA.
To the circle IA?
Opo, and IB.
What do you mean circle IA?
Circle IA, the Excircle IA.
Oh, I sub A.
Opo.
Wait, so wait, kulayan natin ng mga circles. So this circle is tangent to this circle?
The line I sub CF.
I sub CF. Okay, so you're talking about, okay.
Po, yung na-hide po.
Ito, I sub CF.
Opo. If yung extended line po nun, it looks like
parang you feel it's gonna be tangent. Sige nga, tingnan natin.
Tanananan! Not the other
Not
one.
necessarily. Ito, IBE.
Okay.
Hindi eh.
The extreme, pero the extreme coincidence.
It just happened. Pero kaya napaisip din ako eh. Okay, but well, it was well, gano'n naman talaga. We tried to raise observations and then see which of them would work. Okay. So nung points of tangency naman. Points of tangency. First, let me hide itong in circle. And then kunin natin ng no intersection of this circle and Actually, itago ko muna ng mga internal angle bisectors. Kasi now I'm gonna take the intersection. So when I click here, that's gonna guarantee intersection lang ng circle and ng side. So here, and then here, and then here. So you were conjecturing the concurrency of each excenter with
It
the
still
point
looks
of
apparent.
tangency. Tignan nga natin. I sub A to J, I sub B to
Dun, dun,
H,
dun, dun.
I sub C to G.
No, it's real.
All right.
Conjecture. All conjecture
Conjecture,
is
no?
almost. This is a real good conjecture.
Conjecture. So, all right. So, bakit kaya sila concurrent, no? That's a nice thing. One thing I can see is that ito at the points of tangency, ito ng IC to G, we have a 90-degree angle with the side of the original triangle. So kumbaga, itong three lines which happen to be concurrent at that special point, each line is perpendicular to the three sides of the triangle. However, they're not altitudes. Hindi sila
Nor
altitudes
they are
kasi
nor they are perpendicular bisectors.
they're not, yeah, they're not the perpendicular bisectors kasi they're not necessarily, kasi J is not the midpoint of J is not the midpoint of J, G, and H. They're not midpoints of the sides of the triangle. Bakit kaya?
Yeah, proof.
Is it tsaka yung isa ko ba? Is it Colin, is it in the Euler line?
No, is it in the Euler line, no? Anong sa pag-uusapan natin, yun, kaya.
Real
Okay,
real
so ganito. Let me copy this, okay, because that's, hold on. Tanggalin natin to. Oh, okay. In fact, of course, this can be cleaned. Okay. Nagdo-drawing siya ng mga lines na hindi ko kailangan. There. Because we have this, so I'd like to preserve this and take a screenshot. Snip into
Windows Shift S.
For the whole thing. Okay na, na-copy ka na. Ito. I've never tried that. Windows Shift S. Yeah. Copy. And then I'd like to go back to our notebook.
Yeah.
So the points of tangency are G, H, J. So G, H, J are the points of tangency of the X circles with the sides of triangle A, B, C. And then show that okay. Oh wait, hold on. Okay. So conjecture. Wait. Conjecture. A wait. Ang kinanak natin, ito. I sub A, J, I sub B, H, and I sub C, G are concurrent. Okay, that's interesting. Right now, I have no answer pa. Pag-iisipan ko pa, baka sobrang matagalan tayo. But what this reminded me of is the following particular problem, this time in terms of a triangle and its incircle. So I'm gonna use the green marker. Okay. Tapos, di ko alam kung circle or triangle gagamitin ko.
I will use the green I will use the green the green pen. And then
Okay.
the secondary color pen between the blue and yellow.
Okay.
The secondary color between blue and yellow digital digital marker on Microsoft OneNote for Windows 10.
Ito. Kasi baka makatulong to. Okay. So we have A, B, C. Uy, galing na nag-straight. Nagamit pa rin yun ng tool. Okay. Wasn't expecting that. Tapos ito. Drawing natin no incircle.
Parang that looks like the incircle po.
Okay. And then these are the points of tangency. X, and then say this is the incenter, then say this is Y, and then this is Z. Okay. Show that AX, BY, and CZ are
concurrent to the incenter.
Actually, we don't know that. Show that AX, BY, CZ are actually I don't think so. Kasi ganito no. Their point of concurrency, is it gonna be the incenter? Hindi kasi ganito no. Ito nung A going to the incenter. Here is AX eh. So AX definitely cannot contain the incenter because that's the incenter I.
Interesting
Okay.
interesting Chevian concurrency.
Oh, so it's another one, diba?
Parang yung isa rin po, interesting Chevian concurrency din.
So
Provable by Cheva's theorem. I found the answer.
Well, what do you mean? How did you find the answer? Nag-search ka?
Maybe it could be provable by Cheva's
By
theorem.
Cheva's theorem. Kasi actually, in this case, yes, I invite you to do that. Kasi diba, if X, Y, and Z are the points of concurrency, then there's something we can say about the length of BX and BZ, diba? So they're equal.
They're equal. All of them are equal. Cheva's theorem. Real.
In fact, this particular point of concurrency has a special name. Okay. The point of concurrency. So I'm looking at my reference. The point of concurrency is called okay. I don't really know how to pronounce this. Is it Gergonne or Gergonne? Point of triangle ABC. Okay.
Dapat ipangalan po natin itong point.
Okay. Pero ito naman, back to your conjecture nung concurrency natin, ay ano ba itong IAJ, this one, itong IAJ, let me try to emphasize it. Ito, for example, this one, IAJ, ito, hindi siya champion of triangle ABC, eh. So, I mean, okay, IAJ is a champion of the orange triangle from the Excenters. However, if you're going to use Chavez theorem, parang kailangan alam mo nung length nito eh. And from this point here, so let me from here going to there. Hindi ko alam paano hanapin ang length niyan eh. I cannot think of a way to figure out the length. So if we're gonna justify this concurrency here, I don't know if it's Chavez theorem that we want to use or something else. I don't know. Pero ako, it feels like kung something special with IA and J. So I mean we have a 90-degree angle there. So this is perpendicular to that.
I will prove my conjecture.
Yeah. Please do that. I'd be interested to see. This is also something that is not, not in my mind. So, tignan natin. Okay. Other things for you to try, Max. Other things for you to try. Okay, just do as many as you can.
Green triangles.
Green triangles tayo. Okay. Ito, show that
blue yellow secondary color 3-sided polygon.
Okay. Show that the product of the three sides equals 4 times the product of
extended law of sines. I'm sure.
Oh, yeah. So, malamang extended law of sines para mapasok yun doon. Dapat andito din in radius. Okay. Ano pa? So, A, B, C is the... Okay. Next. Triangle. Let R sub A, R sub B, R sub C be the radii
of the in circles.
Of the, tatlo to. Not the Excircle, but the Excircles.
I think po yung above problem, because may SR, it will involve the area.
Yeah, area. Malamang may area.
Diba po 2R is the A over sine E something. So it must be.
Tapos sa mga area na
rather suspicious.
baka mapapasok.
They are also
ayan. And then, madami mga identities na pwedeng paglaruan. But I think that is precisely how you would start. Go through those things. Okay? Para halimbawa, nung SR, na-relate na natin to sa area eh. Diba? This is area of A, B, C, and then try to take it from there. Okay. So let RA, RB, RC be the radii of the excircles opposite A, B, C, respectively. Now, for a triangle, we have 3 circles that we can associate with it or vis-a-vis bisector. So we're not including the circumcircle, so just the in-circle and the excircles. There are now going to be 4 radii, the in-radius and the 3 x-radii. Show the following.
Oh no.
And then we have, little circle. And then one other circle. All right. So all in green.
Funny no-sided polygon. Conic section that is a special case of an ellipse.
Okay, eccentricity 0.
Colored in a rather dark blue yellow on a composite secondary color. that is being currently drawn in OneNote for Windows 10.
Okay. Okay. So these are three formulas, three expressions that are symmetric with respect to each other. So it will suffice to justify that the area is equal to one of these three. So kunwari pili ka lang S minus A times the X radius of A. At A. And then furthermore, okay, it turns out that 1 over R sub A plus 1 over R sub B plus 1 over R sub C equals 1 over, what do you think?
The in radius.
Yeah.
What?
Yeah.
Literal harmonic.
Gosh darn. Okay. So, medyo matagal akong hindi nagbigay ng gawain, no? So, I hope this makes up for it. Anyway, just try what you could. Okay. Ako right now, as we speak, I don't have a proof. Kahit ako doon pag-isipan. So, siguro pag-isipan na lang natin to. And then, so you mentioned familiarity with the Euler line, right? So na-encounter mo nung Euler line, and probably also the 9-point circle.
About 9-point circle in Euler line.
Paano mo sila, in what context did you encounter them?
Is there sort of an analog for the 9-point sphere, tetrahedron?
So, yung
Ooh,
mga na-encounter niya po kasi itong mga yung mga meron po kami mga AOPS na books.
sa AOPS, okay.
AOPS saka sa Google. sa
Okay, alright.
Wikipedia po.
Okay. But so, anyway, it seems na basa mo na naman tong mga ito, di ba? So, nadaanan mo na.
Abo.
Okay. Wait. Okay. So discuss pa ba natin or alam mo na?
Hindi, discuss po natin kasi minsan.
Right. Sure. Okay. So let's just take this session as, we're just going through, we're looking at a figure, we are investigating the figure, and then we're trying to draw observations out of that figure. Okay. So I'm gonna go back to GeoGebra, and for you to be able to use it as reference, I'm going to take a screenshot later. Tapos ididikit ko doon sa notebook natin. Should I save this? Hindi na, kaya mo naman itong i-reconstruct on your own, di ba? If ever you have a need for it. Okay, so don't save. So gawa tayo ng bago. And then let me choose A, and then B, and then C, and then I don't need the axis. So I just need the sides. I don't need the lines out of those sides. But biglang kumapal mong sides. Anyways, again, that will do. But I don't want these labels for the sides. So let's not show the label. Okay, GeoGebra is shared. Okay. What I'm interested in looking at, however, are the midpoints. So that can be done easily in GeoGebra.
Literally.
Okay. So, gusto kong liitan ng kasi ang kapal ng paano ba ninipisan to? Segment. Oh, okay. 5. Going from 5 lahat.
Real.
Okay. Ay, ba't siya bumalik? Anyway, so that's a median, the one that I just drew. And do you see that it's parallel to the side BC? Yeah?
Abo.
Parallel siya dun sa side BC. And in fact, the medians, they're going to be parallel to a side of the triangle. Hala, nag-default siya na makapal. Okay, anyway, ninipisan ko na lang. Okay, and then what observations can be made about that triangle, for example? No triangle na yan.
It's the medial triangle.
The medial triangle. So among other things, the area niya is
1/4, exactly.
1/4. And is the medial triangle similar to the original triangle?
Yes, just opposite.
Opposite orientation. And furthermore, well, since they're similar, what's the ratio of similitude?
1/2.
1/2. Okay, so that means every segment belonging to the medial triangle is 1/2 the length of the corresponding segment from the original triangle. Okay, when we use the ratio of similitude, most of the time in textbooks, we just apply it to compare the corresponding sides. But actually, the ratio of similitude exists between corresponding altitudes, corresponding the lengths of corresponding angle bisectors. The same ratio exists. Okay, as long as the correspondence is established. Now, in this figure, I'd like to supplement this by drawing as well. Let me transfer D, E, and F here. So let me, okay. So of course, if I connect the medians, that's gonna lead, they will intersect at the centroid. So ayan, color code natin, the point of intersection, that's the centroid, that's, oh, perfect, G nung lumabas. Okay, pero color code natin. As far as the medians and centroids are concerned, ito, length 5, and then let's hide the labels, and then color green, this kind of green. So nung G, the same color green. Okay. And then, if ipansinin mo, FG to GC, diba? FG is shorter than GC, where FG and GC are from the median FC. What's the ratio of the lengths of those two segments?
1:2.
So 1:2, right? Okay. All right. So that's a point that we're gonna go back to, but the centroid divides each median in the ratio 1:2. So the shorter part is 1/3 of the length of the entire median. Okay. Now the triangle ABC has many different centers aside from the centroid. There's the incenter, which for now we're not going to look into. The other two are going to be the orthocenter and the circumcenter. Okay, saan ba manggaling ng circumcenter? The circumcenter is what we get when we look at the intersection of the perpendicular bisectors. So let me draw the orthocenter. So by drawing some of the perpendicular bisectors. So ito, through D, perpendicular to BC. And then through E, perpendicular to AC. So that's another perpendicular bisector. So this black point of intersection, which came out as H, that's the orthocenter. So let's relabel that. That's point. Wait, sorry, not this, the orthocenter. Okay, this is the circumcenter. O. Okay. Now, tanggalin ko para hindi makagulo masyado the lines. This one and well, okay. Before I hide that particular perpendicular bisector, let me take this intersection. Okay, so this line contains the perpendicular bisector of BC, but observe that it also contains an altitude of the medial triangle DEF. Because at that point, which is currently labeled H, we have 90 degrees there. But I'm gonna remove the label H kasi we are reserving H for the orthocenter. But let me point out the angle here. Okay. So we have 90 degrees there, and then we don't need the label naman. Okay, and then let me hide this line. All right, and then ito. And then let me recolor. Okay, so basta may kinalaman sa perpendicular, ito, ano naman, orange naman. Tapos nung line, ng segment, sobrang kapal. Gawin natin 5. And then nung label na R, tanggalin natin. All right. And then, so and then this point, I want to remove the label. So that orange line, this is an altitude of DEF. Okay, so you said the medial triangle is similar to triangle ABC. Tapos, the vertex D of the medial triangle corresponds to the vertex A. So if we drew the altitude through D for the medial triangle, let's look into the corresponding altitude of the original triangle. So the altitude through A. Okay, and then, so this is the foot of the altitude. So of course, I'm gonna remove the label kasi I don't want that to be I. I is the Excenter. So tawagin lang natin.
I is the Excenter po.
Yeah, I is the Excenter. Wait, what did I say?
Bisector eye care specialist now.
The Excenter. Okay, I see what you did there. Okay, ito. Okay. Kapal. Siwa ako. Okay. Show label and then style 5. And then palitan natin ng kulay. Red naman. All right. So the orange segment and the red segment correspond to each other, okay, because they're corresponding altitudes, and they therefore follow the same ratio of similitude, 1:2. So of course, it's kind of obvious that the orange segment is half the length of the red segment kasi if you imagine the side BC as horizontal, then the medial line FE is also horizontal halfway through from the base going up to the vertex A. So orange segment is half the length of the red segment. There is another point that na-drawing na natin, O and G, orthocenter of original ABC, centroid of original ABC. I'd like us to look into the orthocenter of the original triangle ABC. The orthocenter is the intersection of the altitudes. We have AK and altitude. Let's draw one more altitude. Let's say the one through B. So, but of course, again, I don't want that label. J naman. Okay, then this line, not really needed. I need that.
9 point cent.
So, style 5. Okay. And then label B, let's use red. Okay. And then on intersection here, that's going to be the orthocenter H. Rename H. Wait. Rename H. Okay. And then red. Okay. Medyo kumpul-kumpul ng mga points. Let me see if I can they're too crowded.
As you can see po, as you are changing the size, it's still the points still remain collinear.
So ng HGO.
Maganda nga po
collinear.
kung igalaw-galaw niyo po para makita niyo po yung collinear.
Di ba, para makita ng collinearity. So that's one of the things that we're gonna prove why they are collinear. And so if they're collinear, there's a line passing through them, and you've probably already encountered this line. What's the name of this line?
The Euler line.
So the Euler line. So why are HGO collinear? And one argument that can be presented here is simply based on similarity. So now since we already have this illustration, sige, let me try to see if kaya ko pang i-modify nung drawing so that mas hiwa-hiwalay sila. Medyo nagkukumpulan kasi. Ayan, at least ito medyo magkalayo. Medyo magkalayo. And then I feel like the points are too big. It's taking up so much space. So let me reduce the size of the points. So point size 5. So ayan, para okay, mas madaling tignan. Okay, and then since I have that 90-degree angle there, well, pwede kong liitan. Style, size, 20, tapos some other 90-degree angles here. Mamaya ko na modify ito. Also 90 degrees. Where? Then the 90-degree angles, we don't need the label that they're 90 degrees because nandun na naman nung show label 90 degrees. And itan natin. Yeah. Or okay, that will do. And then okay. Yikes, hold on. Yeah. Great. And then back to the notebook. Yeah, perfect. Okay. So Queen, H, G, O are collinear. Okay. And furthermore, if you connect them from H to O, G is going to be in the middle of them. In fact, G divides HO in a specific ratio.
Real.
It's the same ratio we've been talking about earlier. The ratio
Not 1:2. It's like I think it's 2:4.
square root of 3 to the ln of 7.
Yes.
Something like that, right? Okay, HGO are collinear, and OG to HG is 1:2. Okay. We call the line containing HGO the Euler line of triangle ABC. Okie dokie. Okay, so we have defined these points, and so we know their properties. So why should they be collinear? So observe the following. All right. The orange. So ganito. H is the orthocenter of ABC. Of triangle ABC. Now, O is the orthocenter of ABC. But what is the role of point O in triangle DEF?
It's the orthocenter.
Yeah, orthocenter. Okay, orthocenter. So H and O correspond to each other. So kumbaga, ito ng triangle ABC and triangle
Okay, so that's
DEF,
why
diba?
the ratio is 1:2 because the ratio of the middle triangle to the original triangle is 1:2.
Yes, so yan. So A to D, tapos as nung orthocenters nila, they're gonna
They have the same centroid eh.
ba't ito nag-a-adjust nung ano nung so H matches with O. Oh yeah, also actually they have the same centroid. Okay? So tapos G is so centroid. So pareho. Okay, so that's another good observation. Okay. Wait, how do we know they have the same centroid?
Uh, uh,
How do you know
uh,
that G is the centroid of the medial triangle DEF?
uh,
Sige. Okay.
I mean,
Claim ito. Claim here. Okay. G is also the centroid.
it's a very simple fact and it's very easy to know. But then I'm at a loss for words to how this.
It's so sublime that you have no words for it. Instead, even with your best attempt to articulate the argument, you cannot do anything else but cry because it's so beautiful.
My intelligence is beyond is beyond the is beyond the capability of the capability of even uttering a single word about it.
Look at ito. Look at ito. Tingnan mo, Joshua. Ito. A, F, D, E.
A F D E A
So
F.
that's a quadrilateral. What's so special about that quadrilateral?
It's a parallelogram.
It's a parallelogram. And in that parallelogram,
The diagonals bisect the other diagonals.
yeah. So the diagonals intersect at their midpoint. Okay. So that means where they intersect here, that's the midpoint of the diagonal EF. Okay. So that makes D and then this particular point a median. All right. So actually, you therefore get inside DEF, the green segments are the medians. Their intersection, G, must therefore be the centroid of DEF. Okay, so lagyan natin ng argument. After I get to erase these other things that I want to erase. Okay, mamaya na. Ayaw pa magpa-erase. In fact, ayaw nga din. Okay, gumagalaw na ang notebook. But ayaw magpa-erase. Okay, di naman ako nag-copy. Okay. Ba't ako pinaparusahan? Why am I being punished?
Ano ba yun? One copy paste equals one punishment for your eternity.
Oh, okay. Ito, alright. Nag-refresh na siya. Alright. G is also the centroid of DEF, so that's because, note that, since AFDE wait, sumusuko ng one note, that means need to close and launch it. Flicker siya sa side ko.
Hindi lang siya sumusuko, napagod na po siya sa mga scenes na po. It decided to it left your computer po. Ayun daw po yung yung mga
So since AFDE is a parallelogram, okay, DA intersects, okay, EF at its midpoint. Okay, so DA, okay, contains a median of, so the median DA of ABC contains a median of DEF. So DA contains a median of triangle DEF. Okay. So the medians of triangle ABC contain the medians of triangle DEF. And then thus G is also the centroid of DEF. Oh, so right. So back here, G is the centroid of DEF. So yeah, so we pointed out that particular correspondence. Okay, and then H is, and then O is the orthocenter of DEF. Okay, tapos ganito. So therefore, because of the ratio of similitude, okay, so ito, sulat lang natin. DEF, similar to triangle ABC with ratio of similitude 1:2. Okay, so ibig sabihin, if you compare DO with ito, DO with AH, that's going to be 1/2. And then likewise, ito, O, what did I use ba? OG, so ito, OG and HG, okay, OG to HG is equal to 1/2. So actually, as far as this ratio is concerned, so ayun, napakita na natin nung 1:2 ratio. However, of course, the collinearity is something else to be proved. So bakit collinear ang HGO? So what we're going to do is we are going to consider the following triangle, the following two triangles rather. A, H, okay? Okay. Ayaw kong patungan kasi I spent a good amount of effort color coding the points tapos tatakpan ko lang ng color. Okay, ito. AHG versus what color? Gray naman. Ito. DOG. Okay. Are
Gamitin
they
niya po yung
similar?
Gamitin niya po yung golden na something space po na font. Space po na color.
Which one? This one? Ito nasa baba?
Yung crazy po ng mga colors or something.
Ito. Eh, mas makikita lang yun kasi kapag may shade ka. I guess, sige, pwede yan. Okay. Mamaya, try natin. Okay. So ito, nung triangle AHG and DOG. So, blue boxes sa vertices ng AHG and then silver boxes for the vertices of DOG. Are they similar?
Yes.
Okay, they are similar. Actually, hold on, wait. Similar bucket, but still similar.
But still similar. Good question. Okay.
Actually, isa pang gusto kong isama dito. Since G is the centroid, okay, we pointed this out earlier. Since G is the centroid, okay, what can we say about DG over AG?
One is to two.
So 1:2. So ito, balikan natin nung two triangles yan. H hag, okay, ano na, para dog DOG and AHG. So ito.
The dog and the witch.
AHG. Tapos, ito, hindi tayo sure sa collinearity with also medyo, iibahin natin ng direction nito. So, ganyan. O, and then D. And then this is O. Okay. Actually, wait. Parang dire-diretso eh. Dire-diretso. Medyo ibahin ko ng ano. Okay. So, observe that we have OG is to H. Wait, actually, ang gusto kong gamitin, ito, for now.
Real.
So, DO to AH equals DG to AG. So if you look at what we are comparing here, we have DO over DG equals AH over AG. So what are these? Nung DO over DG, it's this ratio, DO over DG. DO over DG. And then the other ratio is ito, AH over AG. So the ratios are equal. Furthermore, what can be said about this angle and this angle? Let's go back to the original. So see those two angles are marked in red. Ito yan sila.
They are parallel, so therefore they are equal.
Okay. So kasi nung AK and the red and orange segments are both vertical. So they're parallel. And so therefore the red angles are alternate interior angles. So they're equal. Okay. Also, okay. H AHG, wait, HAG, HAG. Wait, actually dito siya. HAG equals ODG. And then if you combine these two statements, the conclusion out of these is that, what can we say about triangle AHG and triangle DOG? They are
Similar.
similar by
By SA?
SAS. So, of course, no SAS congruence. So we are matching corresponding sides have the same length, corresponding angles have the same measure, but the SAS similarity, of course, we're not requiring equality of the lengths, but rather the same proportion among the segments. So ito mapapansin mo, nung mga corresponding segments with the same marking, in blue and in orange, they follow the same ratio of similitude. So that takes care of the S and S. And then the angle between those relevant sides are congruent. So therefore, we have the similarity of these angles, which means corresponding parts are congruent. In particular, if you now look at these two angles, which I'm going to mark X and Y, what conclusion can we then draw about those angles?
They are congruent.
They are congruent. And because they are congruent, so parang mangyayari ganito. Nung AGD, ano naman talaga yan? Collinear yan. Tapos here is G, and then here is H, tapos X. And apparently, okay, from G to go to O, where the angle is Y, but then Y is equal to X.
So it means HGY is collinear.
Yes, or actually not Y, but O. So that's it.
Real.
So that's the collinearity that we're that we're gunning for. Okay. So yeah, that's how we can conclude they're collinear to each other. Okay, so kung makikita mo, similarity lang ng ginamit natin dito. And then mga facts that we have already established ng mga ratio sites. Okay, so let me point out AGH is equal to DGO, which means since AGD are collinear, then it follows that HGO are collinear. So this justifies the definition of the Euler line as a line which passes through H, G, and O because they are truly collinear. And then the ratio of sides, OG to HG, 1:2, is something that we have already noted earlier. All right. Okay. I know that you have to travel to a party.
Apo.
No, okay na. So I guess we can stop here.
Okay po.
Okay po.
All right. Okay. Sige.
I will thus prove my my conjecture.
Yeah. Okay. So there are well your work is is here. Okay. Cut out for you. All right. Okay. Have a good day. Bye bye. Take care. Adios.
Bye bye po.
Bye bye.